And this is the third and last part for that chapter 24 on lipid metabolism. Again, it's just a summary looking at what happens once fatty acid enters the cytosol of a cell that needs energy, where you have three successive processes: activation, transport, and oxidation. Activation is when the fatty acid must be activated by conversion into a fatty acid coenzyme A. And this is the same purpose as what we encounter the first step in oxidation of the glucose through glycolysis. Number two, transport. The fatty acid coenzyme A must be transported from the cytosol or cytoplasm of the cell into the mitochondrial matrix. Remember, the mitochondrion is the one that is going to be generating that energy. And then oxidation. Fatty acid coenzyme A must be oxidized in that matrix to produce the acetyl coenzyme A and the reduced coenzyme that we use in the making of ATP. Very, very important to know that if you have those examples, best estimate to that 1 mole of glucose, which is about 180 grams, gives you 38 mole of ADP. Now, 1 mole of lauric acid, which is barely 20 grams above, so 200 grams, generates 95 moles of ATP. So fatty acid yield nearly 3 times as much energy per gram as carbohydrate. So many times when you look at the food nutrition facts, you'll see carbohydrates give you 4 calories per gram and fats and oil give you 9 calories per gram. Just keep that in mind. Even if you have a diet that is pretty low in carbohydrate, if you add fats and oil, you do more than double the amount of calories you ingest. So what happens if the lipid catabolism produces more acetyl coenzyme A than the citric acid cycle can handle? Well, we're going to have here different processes, and some of them will be storage. Here, 3-hydroxybutyrate, acetoacetate, and acetone are known as what we call ketone bodies. They are water soluble, so once they are formed, they are available to pretty much all body tissues. Another thing important for you to know is ketogenesis. That's the synthesis of the ketone bodies from acetyl coenzyme A. So what happens in the body? When the energy production from glucose is inadequate, the body must respond to the need of energy by finding other sources, and the production of ketone bodies is going to accelerate. If you look at the early stages of starvation, the heart and the muscle need absolutely to have glucose for the brain especially, so they are going to burn acetoacetate. If you get into prolonged starvation, the brain can actually switch to just the ketone bodies to meet up to 75% of the needs of energy. So 75%, that's 3/4. Now, those ketone bodies are produced faster than they are utilized in people who have diabetes. And characteristic, acetone in the patient's breath and ketone bodies in the urine. That's what we call ketonuria. And blood, ketonemia. Because 2 of the ketone bodies are carboxylic acid, continued ketosis leads to ketoacidosis, meaning that you're dropping the pH of the blood. The blood's buffer gets overwhelmed and the blood pH drops. That results with dehydration because you're trying to eliminate with an increased urine flow, labored breathing. Acidic blood is a poor oxygen carrier, by the way, and depression that will continue. If untreated, the condition can only worsen, leads to coma, and eventually death. Lipogenesis. Well, lipogenesis is the making of those lipids, biochemical pathway for synthesis of fatty acid from acetyl coenzyme A. So that's a link between carbohydrate, lipid, and protein metabolism. And because the acetyl coenzyme A is the end product of carbohydrate and amino acid catabolism, Using it to make fatty acid will help the body to divert the energy of excess carbohydrate and excess amino acid and store them as triacylglycerol. So I found this online is very complex. Don't retain citrate, all of those intermediate, but just it gives you kind of more connection between cytoplasmic and mitochondrial metabolic intermediate. I think it's kind of a pretty good map that makes you understand that everything is linked. Amino acid on the left, glucose, the sugar, carbohydrate, ketone bodies, fatty acid, and then the concept map from your textbook is, of course, a little bit mostly user-friendly, and I would like you to just review it to understand. We want to hear lipid metabolism, and that is the last slide for that chapter. Thank you.